Our group project is coronavirus cases prediction for the United States. My name is Yu. This is group 16. The problem we want to solve has two. First is how many people would be infected by the coronavirus in United States in the future. For this question, we need to estimate the number of future cases in United States and the number of future cases in each state. The second question is when will the coronavirus end? So for this question, we need to find the peak and the trend of the outbreak. The tool we use is the Jupyter Notebook and the Google Colab, which is the online Jupyter Notebook. In the LSTM model, the package we use includes pandas, numpy, seaborn, matplotlib, skeleton, portly, and in SER model, the package we use includes pandas, numpy, matplotlib, and interactive shell and scipit. The data source of the coronavirus 2019 in the United States is from the New York Times. So the data set we use is from the 2020 January 21st to the 2020 May 8th. The country level data structure include the date, country, state, flips, cases, and the deaths. The flips is the zip code. For the data preprocessing, first we use the isNum function to check whether the data has the num value. And second, we transfer the date to the datetime, years, months, and the day of week. Third, we drop the date. Fourth, we group by the date of the cases and group by the dates of the deaths to draw the graph, cases and the deaths with the time series graph. And six, we group by the state of cases and the deaths to get the top 10 states of coronavirus cases and the top 10 states of the coronavirus death cases. For the data visualization, we use the plotted package to draw the map of the United States. The more yellow means this region has more number of cases. More purple means this region has less number of cases of coronavirus 2019. For the LSTM model, we use the normalize function to normalize the training set and use shuffle function to randomize the training set, and the training and the random seed is 10. And we use the slip data function to slip the training set and the testing set in the 20% rate, which means totally 100 days we have 80 days is training set, 20 days in the testing set. Also, we use the process data to process the training set in the 7 days, which is a week. In this picture, it shows our neural network structure, and this picture is our test loss, which is 0.05, and the value is very low. So it caused the overfitting. And for the SER model, the formula in the model is shown as there are four formulas. First is the ST equals ST minus 1 minus K1 times B times I T minus 1 times S T minus 1 divided by N. And then minus K2 times B times E T minus 1 times S T minus 1 divided by N. ET equals K1 times B times I T minus 1 times S T minus 1 divided by N plus K2 times B times E T minus 1 times S T minus 1 divided by N minus sigma times E T minus 1. The third formula is IT equals sigma times ET minus 1 minus gamma times IT minus 1. And the fourth formula is RT equals sigma times I times T minus 1, sigma times IT minus 1. For the parameter S is the number of the susceptible people, E is the number of incubation population, I is the number of infected people, R is the number of recover or death people. K1 is the people exposed to the each day by infected people. K2 is the people exposed to the each day by people in incubation. B is the probability of the transmission when exposed. N is the total population. Sigma is the incubation rate, which is the rate of latent individuals becoming symptomatic. Gamma is the probability of recovery of death. The final parameter is T, which is the state. So the T minus 1 is mean the last date. So we use the last day value to calculate the today's value. For the SEI model, we need to set some of parameter. First is the sigma is equal to 1 divided by 7. The average duration of the incubation is 1 divided by sigma. Because the incubation period of the SARS has been reported to be between 2 to 40 days. So we choose the middle point, 7 days. Second, K1 equals K2 equals 10. So far, we only considered 2020 January 21st to the 2020 February 28th. So in the early time, people who were infected did not get isolation. So K1 can be equal to the K2. But in March, more and more people who were infected will need to be isolated. So the K1 value of K1 will be decreasing. Third, N is the United States population. So from the Wikipedia, we can get the number is 0.3 billion. And fourth, we calculate the gamma. Use the formula RT equals gamma times I t minus 1 plus R t minus 1. So we can know the R, which is number of the recover or death. But in this data set, we do not have the recover record. We only have death record. So also we can know the I, the number of infected people, and the T, we can know the time. So we can calculate the gamma. For each day has a value of gamma. In this picture, we calculate the 109 days gamma. Fifth, we need to calculate B, the probability of transmission when exposed. We use this formula, but in the early time, since the number of infected people is too small, we assume that S equals to N. So we can simplify the formula as IT equals exponential K times B minus gamma times T. We can know the I, the number of infected people, and the K we just calculate, we just set 10, and the gamma we just calculate, and the T, so we can get the B. For the result of STM, so far we get the model. Our model is overfitting. We input the last 7 days data to predict the next day number of cases, which means we use the last week data to predict the 2020 May 9th value, which is 1.2 million and 1,110. The result of SEIR model is from the January 21st to the February 28th. You can see the picture. The original cases blue line is very similar to our I red line. I is the infected number of cases. But when we extend time to the March 15th, the red line is totally different to the blue line in the March. So for the limitation, LSTM has overfitting because the dataset is too small and the result is inaccurate. For the SEIR model, is extremely relied on parameters and formula, and the datasets lacks the recovered cases. In the future work for the STM, we may use the 2003 SARS dataset to train the model and improve the coronavirus 19 dataset in the model to do the prediction. Second, we may set the dropout. For the SEIR model, we will read some articles and news of coronavirus in the US to predict our parameters and import recover cases in the dataset. Thank you.